Hi, this is John. Welcome to Pro Amp Solutions. What we have in the shop here today is a Vibro Champ amp, and this is 67, 68 windowsill, and it came into the shop. This was a find at a thrift shop, and the thrift shop attendant told the owner, you know, when he plugged it in, he got shocked and sparked when he plugged it in. So the first thing I did, I didn't even test that theory. I just took the original two-prong cord out. So here is the two-prong cord, and as you can see, this is original, and one blade is not any wider than the other. So without any ground connection, this could be plugged into your outlet either way, and if you have a leaking or shorted death cap, pow, you get shocked. So as I've said repeatedly and endlessly, and will continue to say, put a grounded cable in these amps and get rid of that death cap. I don't care how much historical value you think there is by leaving one even lay in there. Get rid of them. So now that that is removed, I started looking through this amp. The first thing we'll look at together is the can capacitor, and then on visual inspection you can see the anode side of this 50 UF 50 volt cathode bypass cap for the power tube. You can see that one end of it is blown out. So I don't think we're going to get very far on the tester before we find the electrolytics in this amp are shot. But the meter doesn't lie, and we don't want to guess, so we're going to use science. So I'll bring up my B&K meter here. We'll set it on 120 Hertz, and we'll look at the ESR while we're at it. So we'll look at each of these are 20 UF legs each, and let's see what they say. So that leg says 16 UF and about 3.5 ohms. This leg says 15 and about 3 ohms. And this leg says 16 and about 3 ohms. So at 20 UF, I expect a little bit better performance out of these than this currently shows. So yeah, it's right at about 20% less than what it should be. The ESR isn't terrible. And the other thing I did, the best way to test these is actually to, you know, lift a leg or get them out of circuit. So that's the state of the can capacitor there. And let's look at this bypass cap with the end blown out. Okay, 2.2 nanofarad and 505 ohms of ESR. So that bypass capacitor is providing no value at this point, not doing anything. And then now these other electrolytics are in circuit, but we'll see what they stay. Okay, 29 UF and 10 ohms of ESR. Let's look at the mailery here. 15 UF and 8 ohms of ESR. We'll look at this last electrolytic here. 32 UF and 6 ohms of ESR. So I think what I'm going to do, I'm going to replace the electrolytic caps in this. I've already made a pass at all of the caps. These two chiclet style capacitors, they read a good value, but their ESR is extraordinarily high, as though they may actually be leaking some DC. So I want to get the main part of the power supply fixed in this, and then once we can power it up safely, we'll look a little further and deeper into the amp. The other thing I noticed is this amp, this was just covered with black tape, but I believe this is the center tap for the heater. So once I get the AC supply hooked up, we'll measure from the center to each half here, and if this is the center tap, I'm going to put that to good use, and we will rewire the 6.3 volt heater supply, which is these 3 tubes, and you can see that we have pin 7 grounded here and pin 9 I believe grounded here, and so this one side of the heater supply is grounded, and we can balance that and help further reduce the noise floor. So yeah, the amp came, I'll call this one Sparky because it came in like Sparky, and but we're going to send it out safe and sound and in tip-top working condition. So let me start that work. I'll get the big Weller out, that's the higher wattage iron, so we can lift these tabs, and we'll drop this can capacitor, and I'll do these 4 electrolytic caps. We'll get those done at the same time, and with the new power cord and strain relief, I'll get that part done. I won't rewire the heater system yet. I'll just do the main power filtration and the power cord, and then we'll evaluate the state of the heater and how we want to approach balancing that. There's really 2 ways. If this is indeed the center tap, we'll put it to use. If it is not the center tap, of course, we can just use a pair of resistors to ground to create a virtual center tap for that. So that's going to be my approach on Sparky here, and I look forward to getting the power supply to this amp in safe operating condition with better filtration, and rejoining, and then we'll take a further look at this in the next step. Okay, I was actually going to go through the removal of this can capacitor with you. I've already lifted these 2 tabs up, so these are the 2 we're concerned about now. And then I use these in my shop. I keep a couple of these rubber blocks. They come in really handy. You can orient them for different heights to keep tubes from getting broken, and so on and so forth. So I'm going to bust out the old Weller high wattage, and we're going to heat this up. Hopefully we can get it molten, and then start lifting this tab here. So that's the idea, and just have to be patient, let it get good and hot. Okay, I can feel it beginning to work. There we go. Starting to get the top in more of a molten state. Getting there. Okay, so I was able to scrape sort of the top of some of that off there. Just came off. Okay, take a break here momentarily, get rid of this solder glob, and get maybe a slightly smaller screwdriver to work with, switch hands in here to get some movement on this leg. There we go. Okay. So I've got the leg of this right side here, I believe, freed. We're going to lift it up and away, and then I'm going to reflow just here real quickly, kind of away from it. Alright, one side down. So that side there is free, as you can see. So we'll try the same technique on this other side here. Alright, I was able to put some turning inertia on that one once it broke free. And so what I'll do now is see if I can bend this up. There we go. Okay, so we can see the can is removed, and then I'll heat this solder up here, get it to flow in the area again, and re-prep that for further work when we install the new can. There we go. Okay. Alright, other than kind of cleaning up some flux here, we'll clean this surface here. And we'll get out a Q-tip with some flux cleaner and that area all prepped real nice for the moving forward work here. Okay, so those solder joints are cleaned up and we're prepped for the new can. Go ahead and grab the new can. So this is a CE 2020. That's what we're going to put in there. We'll orient it to the left here. And we'll install this in, I think, like fashion. So the first thing I'll do is bend these two tabs over to retain the can. Okay. Okay, so there you have it with some solder wick. I was able to clean up this side, so I like that technique a little bit better. That way we'll get a good flush leg down and can work on heating that and introducing some solder. Well, that's not going to help me, at least not for this. Okay, we've got the new can installed. Let's test the new can with the same criterion. See what it shows. So we'll set our frequency at 120. Look at our ESR, and let's see what a brand new Mallory can cap does. Sorry, CE cap. There we go. 21.6, .2, and 21.6, all with an ESR of about 3. So we'll have better filtration there. That's nice. And then I'll replace these for electrolytics here, and we'll rejoin. The other thing I'm going to do is the other leads on the other can were just put through. I'm going to strip a little more material off there, and we're going to wrap a nice mechanical connection on the top here. That is really the best way to do that. Okay, so we have a soldered grounded can capacitor installed, and we've got our 320 UF legs. So we'll implement that. We'll replace the bypass cap. And then these are also cathode bypass caps for the preamp tubes. And then this guy here, this is supposed to be, I believe, yeah, interesting. I'm not sure why there's just one of these. We'll keep on moving through the video, and I'll come back shortly. Okay, I wanted to show the detail of what I do when I lead dress these. So I've, I don't know, got about a ½ inch of the cloth sheet off of this wire. And what I do is I go through the hole, and then once I'm through the hole, I wrap it around and tighten it down so we have a really tight, solid mechanical connection in addition to a nice solder connection. So there we go, just beautiful. So you'll never have any trouble with those leads. So we have our main filtration is now completed. So lead dress that like it was, and there we have it. There are our 3 legs of 20 UF each. So I think I'm anxious to get the power cord in, and just to have a strategy with the heater. Not too concerned right here, right now. I don't have any tubes in it. We're not going to attempt to run the amp, but I am concerned about the power supply condition. So I think what I'll do is get the new power cord installed with a strain relief, and just put a rectifier tube in it, and test the voltage rails, and test the heater circuit. And if that's the center, then we'll have our strategy. I'm pretty sure it is, but we'll verify. And Okay, I'll get the power cord in and we'll come back. Okay, welcome back. I've got the new power cord and strain relief installed, and I was going to do a quick voltage test, test the high voltage rail. So I've got the rectifier tube in, it is tubed. We're not concerned about audio right now. I'm going to check the three DC high voltage rails, and then we're going to check to see how balanced what appears to be the center tap of the heater is. Alright, so we'll turn it on, and so this here is the plate, and as it starts conducting, we'll see this voltage come down. There we go, so the power tube is conducting, and we'll see this voltage drop. Let's see where we end up. Okay, looks like it's okay, looks like that's stabilized around 313 volts there. So then our next stage is 293, and our last stage is 273. So that's where our voltages are with this rectifier tube. Yeah, I'm happy with that. Let me put the meter on AC, and then we should see on pins 4 and 5 here, we should see there's our not quite 6.6, so we should be about, if we're half of that, so let's see what this center is here. 3.29. Beautiful. Okay. Okay, so we do have a heater center tap here. So we'll lift the grounds from the current 6-volt heater supply. So the basically the amp here, it is grounded at this socket, grounded at this socket, grounded at this socket, and then the lamp leg is also grounded. So I'll have to lift those 3 ground points on each tube socket, and I'll probably remove this lamp assembly to make that desoldering a little easier. One of those legs for the lamp has been spun around and soldered to the frame. So we'll get that off, and then I'll take what is this lead and we'll run it over to the other side of the lamp. It looks like it's long enough to do that. I'll put a J-hook in this and extend it slightly. We'll cover it with heat shrink, and this will be the center tap, which will now go to ground, and then we'll pick up the heaters from the lamp and run them back across the back in the corner and up, down and up, down and up, and we'll have a balanced heater supply. So I think that's what I'm going to do next, actually, is I'm going to go ahead and remove the grounds and balance this heater supply. And on my last video I showed the 20 gauge solid core. I'm going to use that same technique on this amp. We'll redo the heater supply, we'll balance it, should help the noise floor on this amp, and then once that's done and we verify the power supply completely, then we'll go on to the signal path and make the required changes there. So that's where we're at, and it's no longer Sparky, so I am excited about that. I can touch the chassis here without fear. So we've got a 16 gauge power cable in here grounded to the chassis. We're switching the hot leg, and the neutral leg is going through the fuse into the transformer. So that's that, and we are now safe, and we're filtered better with the new can, and voltage is looking about what I would expect for a 5Y3. So onward and upward. I'll get the heater wiring in and we'll rejoin. Thanks for watching. Okay, welcome back to ProAmp Solutions. As far as incremental progress goes on this Sparky Vibro Champ, we've got the power cable installed and grounded to the chassis here. I extended the center tap for the heater, put J-hooks in the soldered link there, heat shrink, and it comes now down to the ground point. I twisted the heater wires going to the lamp and then created a tightly twisted heater supply for the rest of it. I'll tilt it back here so that you can see the implementation of the tightly twisted heater supply, and that is looking good. So at this point I am ready to power it up. We'll use the current limiter, but let's check the voltage rails together. So I'll put the current limiter on and we'll flip the amp on here, and let's get the handy dandy meter out and see what things look like. So the first thing I'll do is we'll make sure you can see the meter here. Alright, move it here. Alright, so we'll attach the meter to a ground point, and then okay, so we'll turn the tremolo, make sure it's all the way off. Okay, so let's check our high voltage. Alright, 362, 358. So around 350-ish. That looks good. Alright. So this is now at the plates. This is the screen. And then this is the downstream power supply. Okay, that looks good. Let's switch this to AC and let's see what pin 9 looks like. 2.4 and 2.4. Now this is current limited, so the voltage is going to be a little bit less. I wanted to make sure that my lamp did not go way up. So now let's take the current limiter off. Okay, so I have just switched the current limiter off, and let's check the heater supply. So there we are, 3.3 and 3.3. So a perfectly balanced heater supply. Let's revisit the high voltage with the current limiter off. So out of the rectifier, there we go, 316. And the reason it's lower now is because I had the current so restricted, the power tube was not able to draw much current. So at the plates, 316. At the screen, basically high 200s, close to 300. And then downstream, we've got 276. So that is the high voltage. The balanced heater supply worked. I don't have an audio speaker hooked up to it just yet. Our tonal quality will not be optimized. The next thing I'm going to do, I'm going to replace these 4 electrolytics. I'll tell you what, one thing I will do while I'm here, just to demonstrate, I want to make sure that there's no DC leakage on my coupling capacitor. So this chiclet capacitor right here, on one side, we're going to have the high voltage supply to the tube. Okay, so this is the supply side right here, 275. On the plate of that 12AX7 we've got 189, and then I'm going to come across and see if we have any DC leakage. So very, very minor in circuit. That's not too bad. So that's that one. Let's see if we have any DC leakage on the tone stack side. So this is at the plate of that 12AX7, and then this will be the 3 respective capacitors. There's no DC leakage there, no DC leakage there, and no DC leakage there. So as long as these caps test in value good, I don't see any DC leakage to be concerned about. And then I have one more chiclet style. This is the first coupling capacitor here. I've got Obviously the tremolo is oscillating, so we see the fluctuation there. But on this side, I should have no DC, and we have no DC. So that part is looking pretty good. So as long as these chiclet capacitors and film capacitors test within their tolerance, it looks like we'll be okay. We're going to replace these electrolytics and then fire the amp up for a bench test and see how it goes. So I'll replace these. Obviously we saw that this cathode bypass capacitor on the power tubes, it's blown out. This doesn't really have any capacitance at all. So at this point our tonal quality is going to be terrible, and that may actually be wreaking some havoc as far as the current in the power tube. So we'll get these electrolytics replaced and come back and do a bench test. Look forward to joining you when I have that complete. Thank you. Okay, I wanted to show another observation here that is meaningful. So as we go through it, I continue to test. Well, I wanted to show you, this is the power tube cathode bypass capacitor that was removed. We see the end blown out here, but look at the damage from the bottom side here. You can see how overheated it was, and it actually looks kind of burned out there in the center where it was adjacent to the resistor. So we'll make sure we have a little more separation, because obviously that cathode resistor on the power tube generates some heat. So it caused me concern, and I wanted to check the reading. This is supposed to, the color bands are very dark from overheating, but this is supposed to be 470 ohms, and it's 415 ohms. So I'm going to replace this cathode resistor with a nice, probably like a 3-watt wire wound, and then put the bypass capacitor in it. So the plate voltage looked slightly low to me, so this may have been just drawing a little bit too much current. So we'll fix that. We'll put a brand new 470 ohm wire wound in here and put the proper Sprague 25 UF bypass capacitor in here. So as I'm going down, doing some testing, and wanted to show that on the meter. Okay, welcome back. So I have the new 470 ohm 3-watt wire wound cathode resistor in for the power tube, and a Sprague Atom 25 UF bypass capacitor, and you'll see I have separated the cathode resistor as it dissipates some heat from the capacitor. They're not touching like they were in the original installation. This is the bypass cap for the tremolo here, 25 UF. This is a bypass cap for the second gain stage, 10 UF, and then this is the 25 UF bypass capacitor for the very first stage. So everything looks good. What I'm going to do now, I'm going to power it up, and I'll connect a speaker to it. So I think at this point we can test the noise floor, do a brief audio test, and see where we stand. I also want to do, before I turn the volume on and do some audio, let's test the voltages. Let's see the dissipation in the tube. So what I'll do is we'll see what the plate voltages are, and then I'll measure the voltage across this resistor, and we'll be able to determine how much dissipation that power tube has. So we'll go through that exercise together. Alright, I'm ready to do that. So I'm going to power up here, and we're powered up. Get the meter here where you can read it along with me. Let's set this on voltage. Okay, so get to a ground point here in the corner of the chassis. Okay, so give this a second to warm up. We'll look at the plate here. So you can see what a large difference this has made in the amp. We were drawing apparently way too much current and stressing the power supply. So look at the plate now. Isn't that beautiful? So 383 volts at the plate of the power tube, and then the screen 372, and then our downstream power supply 346. So that's much more in accordance with the schematic. So we definitely uncovered a problem as we were going through it. So continual observation and testing really pays off. So let's see what our voltage is at the top of this resistor. So we've got 20, let's just call it 22 volts DC. So let's do the math here, and we will take 22 volts divided by 470 ohms, gives us 46 millivolts of current. And let's see, that was with a plate voltage of 382. Just keep it simple math. So 382 minus the cathode voltage of 22 would be 360 volts. So times 360, and we are dissipating 16.85 watts, which this has an electroharmonic 6v6 rated at 14 watts. So we're a little over 100% dissipation on this tube. So it was in bad shape, drawing way too much current. Now our voltages are healthy. Our dissipation's a little high, but not over concerning. For this amp, it's fairly standard and consistent. So our voltages line up with the schematic now, which they really came into a line. I was a little concerned that those voltages were a little low. That could be a bad rectifier tube, but in our case, we could see the problem there around. And if you look at this, this resistor is just really discolored. You can see, hold it here where you can maybe see a little better how discolored and looks like heat damaged it is. So I think that pays big dividends with the current going through that resistor, putting a nice wire wound in there. So at this point, with the electrolytics replaced, let's plug an instrument in, and let me get a speaker connection made. So we have some audio here. Okay, so I've got a heater going. It's a little cold in the workshop here. Let me turn the heater off. Get rid of background noise. Just a little bit of scratch. We'll clean and lubricate that pot. But there it is, dimed. Okay, basically very low noise floor, if any. Let's plug an instrument in here. Okay, and that is my instrument is grounded, and depending on how I orient it here, we'll see. Look at that, on 5 and dead quiet. That's beautiful. That's beautiful. Let's see what kind of response we get out of the controls. Strum a couple chords here. If I could get my act together. Put that neutral. Okay, so we got good treble control. Just a little scratchiness in there. We'll clear up. Okay, a little scratchy in there. It could be one of two things. We could have a little DC on the pots from leakage, but I think I've tested that adequately. And then let's bring our tremolo up here. Let's see what happens. Nice. There's our slowest speed. Alright, I think I'm pretty happy. Got good control response. That's with the tones at neutral, just a little bit of trim. Different pickup positions. Okay. I am really happy with that. I will clean and lubricate the pots and then get this in its cabinet, and I think we're ready to go. I'm happy with that test and the results, especially how that high voltage came back where it should be and the dissipation there. Again, on a Class A cathode bias single-ended amp here, okay to have at 100% dissipation. In this case, when you play, the dissipation actually goes down. When this is at idle, it's a little hot right now. I wouldn't mind maybe raising the value of this, but it's what's called for on the schematic, and I think we'll be okay. So these beautiful original chiclet capacitors are not leaking. They tested right at about 21 nan a piece, so they were really close. And actually, all of these tested well within their tolerance. So I'm going to leave those in for the vintage value and appeal. So basically on this amp, we have just balanced the heater system and replaced all the electrolytic capacitors, and then of course the cathode resistor for the power tube, which was necessary. And then we have added a grounded cord, and this amp at this point I couldn't be happier with you know, it really pays dividends to balance the heater and lead dress. It definitely matters. So I'll point out a couple of things that I have done here. So tilt this where we can see it a little bit better. There we go. So this is very tightly twisted and laid in the bottom back corner here. And what you'll notice, what I've done here is I have elevated the wires to the speaker here, well away from the back corner here. And then as these come, I bring them up and over, and I keep them elevated away from the grid and cathode and plate wires from each of these tubes. So, and I even pulled away the feedback wire so that there's distance from that, and then, you know, most of that noise is going to cancel with that tight twist. So we're looking really good. We'll keep that in the back corner. And then up front here, this didn't turn out to be too bad. I used solder wick. This leg here of the lamp was actually soldered to the frame here, and I was able with heat and solder wick to clear that out enough to get it to spin freely. Then I just used some cleaning fluids and I was able to restore the lamp. So I come twisted from the power supply now to the lamp, and then I pick up the heater supply at the lamp, and that just worked out really well. So couldn't be happier, and let's get this in the cabinet and we will do a final sound test. Okay, couple of observations here. Wanted to be able to show you the Vibro Champ and its chassis. This was an awesome find for this particular client, and thrift store find, and got a great deal on it. But as we nicknamed it when it came in, it was a shocker. But now, no shock. Yep, safe as can be. So we have a very low noise floor. The amp is powered up right now. And then I wanted to show you some of my final findings in the back. So this has a Weber Classic El Nico 8-inch speaker in it, and the wires going into the speaker terminals were just kind of pushed through and twisted. They didn't have a very good mechanical and no solder connection. So I corrected that, put a nice mechanical connection and soldered those leads, and then have tested the tremolo pedal. But this has a Weber 8-inch classic Alnico, and the noise floor on it is about what I would expect on this. Very low, very, acceptable for what this amp is. And also, as I set up for the bench test here, I think those were my final findings. And I always include in the amps that I return, I always return the takeoffs to my customers. So you will see every component that we replace. The can capacitor, that's the resistor there for the cathode bypass. This is the death cap. And then there's 3 of the 4 electrolytics right there. The original power cord, and the old heater wiring that came out of the amp. So everything that came out of the amp is included here in case this particular client would ever want to sell this amp. All of the original vintage parts are included, of course, with the work that I do. Okay, this is John. I've got the amp chassis back in the cabinet. You can see how beautiful this 1968 Vibro Champ looks. I've got the volume at 3, the treble at noon, 5, the bass at 5, and the tremolo. We'll set the tremolo up a bit here, and let's do a few sound tests. So here is test number 1. Here is test number 2. And here is test number 3.